All right, so this is one last quick walkthrough of some Hardy Weinberg phrasing that you could see on the AP exam or on my test. And I did this in class today, but in case somebody was not here or you wanted a little rehash of it, here are 4 differently worded problems, and how do you figure out what piece of information they're giving you. So for each of these in class, the question was, what is Q? That is what I asked people to figure out. So your solution here, what we want to know for each one of these is what is Q. Now, a couple of quick things that I don't have up here. Remember that on the formula sheet, they're going to tell you a couple of things. They are going to tell you P plus Q is 1. I'll put it here in the corner. And they're also going to tell you that P is the frequency of the dominant allele, and that Q is the frequency of the recessive allele. The word frequency is not the key word, and I cannot harp on this enough, because people see the word frequency and they assume if you see the word frequency, they're talking about alleles. No, frequency is just a fancy word for decimal. So don't rely on the word frequency to tell you what piece of information they're giving you. The other thing that they give you on the formula sheet is that P squared plus 2PQ plus Q squared equals 1. I'm sorry, this is really sloppy in the corner here, but the thing is, you're never actually going to use that formula. What they don't tell you on the formula sheet, which is the most important thing of all that you need to know, is that P squared is the frequency of homozygous dominant, 2PQ is the frequency of heterozygous, and Q squared represents the frequency of homozygous recessive. And that, if you don't know that, that's going to make it very difficult to solve these problems, and that's not on the formula sheet. Okay. So with that information kind of scribbled there in the corner, let's go ahead and solve these 3 problems. So the first one says 20% of individuals carry the little b allele. Now, allele is a key word. If they're carrying an allele, we're not talking about a genotype. We're talking about how common a gene or an allele is. And that keyword tells me that they are giving me either P or Q. And since it's the recessive allele, they're giving me Q. Now, notice this is a percent. So Q is not 20%. Q would be 0.20. And that would be it. That's our first one. Very quick and easy. So to change a percent to a frequency, just a reminder, you divide by 100. And if they were to ask for a percent by some chance, you would multiply a frequency by 100. But again, the word frequency itself is just referring to that it's a decimal. All right. So here's our second one. 350 are black. 150 are white. Black is dominant. Now, they do this on purpose to throw you off because people will assume that if 350 are black, that must be P squared. The problem is, since black is dominant to white, black ones could be homozygous or they could be heterozygous. What we do know, since white is recessive, is that our 150 that are recessive have to be purebred little b, little b. And therefore, 150 over our total of 500 would be Q squared. Again, why? Because those 150 are little b, and remember down here at the bottom, that's Q squared. So, to get Q, we would need to take the square root of that. So we're going to do 150 divided by 500, and that gives us 0.3. Q squared is 0.3. And then if we take the square root of our answer, we get 0.54777, blah, 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 blah. They'll tell you on the AP exam where to round to. You don't want to over-round things because you can, your answer becomes less precise. For purposes of this, I'm just going to take it to hundredths. So 0.55 would be Q. And all I did here was take the square root of Q squared. Okay, now, different scenario. Let me put that here, 0.55. Okay. Black is big B, gray is big B, little b, white is little b. 10% are black. Now, this time, the piece of information, first of all, they're showing a trait, so that means they're giving us one of these 3, the P squared, 2PQ, or Q squared. And in this case, we can use the black because since the homozygous look different than the heterozygous, this is P squared, 2PQ, Q squared. So if 10% are black, we know that P squared is 0.10. Again, just changing our percent to a frequency. So to get P, we will take the square root of 0.10. and that gives us 0.32. And then P plus Q is equal to 1. So 1 minus 0.32 will give us Q, and you're going to get 0.68. So Q in this case is 0.68. Again, showing a trait of black, and in this case, black, the only code for black is big B, so you're getting P squared. And the last one, the frequency of big B is 0.4. So now notice they're talking about a gene or an allele, not a genotype or a phenotype. And so they are actually giving us P this time. P is 0.40. Why do I know that? Because they're talking about an allele. Again, they didn't say the frequency of the homozygous dominant or the heterozygous. They're talking about just one letter, not a set of two. And the fact that it's the dominant one and not the recessive one tells me it's P, because Q is the recessive. So if P is 0.4, then that would mean that 1 minus 0.4 would give us Q, and Q therefore would be 0.6. So there are 4 practice problems, all phrased in different ways. The most important thing in these problems is to figure out what piece of information they're giving you. Once you have that, you can get really anywhere. I would say the only piece of information they could give you that you would not be able to solve anything, just kind of throwing that out there, would be if they gave you heterozygous. If they gave you that 2PQ, let's just say it was 0.65. You can't solve for P or Q from that, because the formulas that you have, this has 2 variables. You need P or Q in order to solve for the one that's missing. So you would not be able to solve if they gave you heterozygous. Also, if it was a case of incomplete dominance, it would not matter. Like, for example, if you had A1 and A2. So, the individuals could be A1, 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 A2, or A2, A2. And they told you that the frequency of A1, A1, let's say, was 0.36. I've had people say, oh, but how do I know whether this is P squared or Q squared? And the fact of the matter is, in a case like this, it doesn't matter. If they're giving you one, you can get the other one, and it really just depends what they're asking for. So if they're wanting the frequency of A2, for example, you could make A1P and A2Q. You could do it the other way around. It absolutely makes no difference. I know that if I need to get A2, and let's just make A1, let's make this P squared. If I make this P squared, then P would be the square root of this, which would be 0.6, and that would make Q, which in this case we're making A2, 0.4. If I made this Q squared instead, it's going to be the same thing. Then Q is going to be 0.6, and that means I'm making A2P instead, which is still going to be 0.4. So if it's a case like this, you don't have to worry about homozygous, which one you're going to make P and which one you're going to make Q. It's going to work out either way, as long as you're consistent with what letters you choose. All right, so hopefully that is a helpful tutorial.